Hello, so today we have part number 4 on developing the robotics simulator with the Unity, and firstly I will show you what we will have in the end of this tutorial. So I will start the Unity and also start the MATLAB program, and the robot start grabbing cubes. Then based on the camera it will detect the color of the object, and then it will be placed to the corresponding place. Okay, we have 3 different objects. We wanna sort them based on their color. So that's what should we get in the end of this tutorial. So here we have conveyor object moving along it, and here we have 2 sensors. Firstly, we will change speed of the cube to the slow one, and here it will be stopped. In automation system, these 2 sensors usually used for more precise positioning cube in a place where robot wanna grab it. So if we'll move with a fast speed, maybe the object will skip this place. So here we need to change speed to the slow one, and here we'll for more precise stopping the object, we change speed to the slow one. Again, if we take a look, so firstly object will move with a fast speed, here it will change speed to the slow one, here it will be stopped. So let's move to our project, what we had last time, and I prepared the asset which we need to import to our project, so it will save our time, so we won't develop some of the elements manually. So this asset also will be available in the description to this video. So we import these things. So here we'll have the test scene 2. As we work with the import scene, so let's also name this test scene as import scene 2. Let's firstly finish with the import scene number 1 and add here some of the elements from scene 2. Here you can see also the tooltips. What's that? If we will activate this button, if we click it, we will see the particular positions of regions where this tooltip is attached. So for example, we can also zoom them in, zoom them out, and it's more convenient because here we can see the some of the positions of joints of our robot. Also we can see the cube, so it will be more convenient to put this data to the MATLAB if we see it on the screen. So firstly, let's also move this tooltip to our import scene number 1. So here we search for this tooltip. Here it is, and here also this tooltip controller. So it has this script, camera, canvas, and tooltip show itself. So we will copy this canvas and we will copy this tooltip. To our previous scene, Ctrl C, and Control V. The tooltip we need to place to the main canvas. So we will sit here and we will move it slowly down. So it will be here. Next, how to operate this tooltip. For example, if I currently click it, I will see nothing here because we didn't attach the tooltip information to our objects. Firstly, we also need to drag and drop our camera here. And next, attach the tooltip to objects we wanna display information. For example, I wanna display information about my robot, of its joints. So we wanna display the base. So we need to attach tooltip information to this object, to the base. So now if we start, we should see the coordinates of this tooltip. So this is the coordinates of our base. So here, if you click here, you will hide the tooltip. Also you have additional buttons. For example, this button will fix it here or unfix it. And also you can remove the line or you can add it. What else we need to display about our robot is joint number 3. So we add our tooltip also here. Next it will be joint number 5. Also the end effector. And also some of the elements, for example these elements, base origin, RGB, and also to all of the cubes we can also attach it. For example, for cubes it's not really necessary because we can see the origins here, so it will be more convenient to attach to these parts. So we selected all of them and drag and drop tooltip information to these objects. For example, now if we will start and click tooltip, we will see corresponding descriptions of all elements. So from here it's more easy to take data to the method. One more thing about it. So here we are interested only in one position. So we can also change the origin to display only one position. So here we only interested in one direction, about top direction. So we can change only this part. Also, let's set it to the joint number 2. And we can shift the joint 1 position to the 0 place, to the base, in order to see the right coordinates here, because now it's not really correct. We need to reference to our base to the 0 coordinate. So firstly, let's shift the joint to the 0 position. So we can make that? We can firstly put 0 coordinates here. For this procedure we need to move this element down, then we can change coordinates here to 0, and then we put it back. Let's check it and put it a bit more down. Then we put joint 1 to our joints. Next we will also make the same things here. We move it out and change joint 1 to 0. Then put it back. So now we have it here, and here we have the correct information. What also we can make, if you take a look to this origin, it's in the middle, but this one somewhere shifted. We wanna move it to the middle. So again, we move these things out. Here we change this coordinate to 0, this one to 0. So we'll leave only this coordinate and put it back. Next, same with joint number 3. We firstly move it out, these things to the center. Why is it changing with some angle? Okay, so here we have also rotation because of this. It's changing the angle. Okay, so here we have angle 5. We can reset it to 0, then it will work fine. Then we put it back. Here we also then need to change the angle. Okay, it will take a pretty long time to adjust. So let's just change one coordinate. Next, we go we also interested in this joint, number 5. Okay, let's leave it this way and also add the vector. We first remove these things out, then change the region of the end effector if needed, and then put it back. So that's all adjustments. Let's try to check. Point clicker 0, 0. Then this point. So we'll see the similar values here. Next, this part. We also should see similar values here. Then these parts, they have a reference to some other parts, so it can be also fixed later, because here we display the local positions. Example of this one, joint number 2, you see these coordinates here are displayed. So in order to see correct values, you need to use correct local positions. Let's also check that the MATLAB program still works for sorting these cubes. And move to the next scene. The second one with the conveyor. So here was MATLAB project and here was the part number 3. Let's make sure that it's still working after our changes. So let's save it and check. Firstly, we will grab the green cube. Again, I have some communication error. Let's let me open project one more time, so I'll close it and open again. Also, probably I need to close two projects because I worked with the previous one before. So maybe I need to close two projects. Yeah, so now it was started. It's mentioned that server has been started, so now we can test the program. Start, move to the green one, detect color. Next, red one. And blue one. Okay, it's working. Let's move to the part number 4 to work with the conveyor. So we go to the scene, import scene number 2, and work with this conveyor. So here we have a different canvas, what it has. Also it has the joints, point clicker, and manual generation of cubes. So this canvas main has a new script, cube instantiate. By this script we create new cubes, cube instantiate. So it has firstly we create prefabs of these cubes. So here are our prefabs of these cubes. So if we will put it here, it will be instantiated somewhere in a space. We want to give it some other coordinates to put it above the conveyor. So we firstly specify where we want to locate our cube. Next, as we make reference to our region, next we need to put it to our base origin, to our robot origin. So robot will know where is our cube. Example, let me start the program, and you will see now that this prefab will be instantiated here with a parent of the base origin. So it's mentioned here to make it parent based on our base origin. So if we will move it out, then you will see the coordinates how we instantiate our cube in the beginning. Exactly these coordinates in space. Also how the cube moves. Here we have move our cube. Here we have two sensors, sensor 1, sensor 2, and we change speed. We have fast speed, slower speed, so we change it in the update. So how do we make that? We detect our sensors, and based on it we start particular coroutine. For example, the first coroutine. Here we don't really need the mesh renderer because I used it before for creating color of the cube. so we can also delete this part of mesh renderer. So we don't really need it. And we will just change the speed of the cube. So here for the sensor number 1, we will change speed to the slower one, 0.3, and for the sensor number 2, we will change speed to the 0.1. Sensors are located here. Sensors, so it has particular tag sensor 1, sensor 2. In our program, we detect this tag sensor 1 or sensor 2. So if you don't know how to create new tag, you can click add tag here and then give it any name, for example, sensor 3, save. Then you will be add a new tag to your object. Also, some more information about sensors, how we detect them. They also have the collider here. Box collider, and we need to use is triggered here. So firstly we use function on trigger, enter, then collider, collider. And if this collided object has particular tag, we start particular coroutine. Next. If I not activate this is triggered object, then you will see that we will won't be able to enter the object. The cube will stop here, so for this we need to use it here, is triggered toggle. Next part. Maybe tooltips already located here as we imported our scene. So here our tooltips. Maybe too much because here camera has two tooltips. It's not really correct. So where is our camera? We need to remove one tooltip object from here. Also check the robot, because when I started it, the gripper was working. Let's check why. Because it's missing our script collider test, so we need to also add script to it. Also some scripts has been lost here, so we need to attach them again. Robot script. We need to edit everything again. Maybe I can copy scripts from our previous scene, because I don't really want to create here everything again. So let's copy them from the previous scene. Open this scene, our scripts, and copy these files. Control C. Part scene, Control V. So we need to have the robot, client, camera, canvas changes, screen to point, also this game object set active toggle. So I'll just put this object here, then I will remove these scripts, delete, name it script. Why can it's missing? Okay, let's just create the new scene manually. So I will copy this scene and modify it based on the scene number 2. So Control C, Control V. Let's make it firstly copy. And open this scene. And then delete some elements here. What we need to delete is from canvas. We delete parts related to the cube. And we copy another part from here. We copy generate cube object from canvas main. Control C, Control V. Put it to the canvas main, panel settings. Close it here. We first point click on the cube's tooltips. Let's make it same. Next, objects. These objects we don't need any longer. We copy from our scene number 2 the conveyor and other objects. This loop. camera conveyor. Again, Ctrl C and put it to our scene copy. Conveyor should be here, and other things move to the base region. So they will be here. So also our camera will be here. Cam C. We need to put it from the robot. Remove from robot end effector and put it to this camera object. So now our camera won't be attached to the end effector, it will be attached to this object. Where was our camera? Okay, here our camera. So now our camera will be here, so we can just delete this camera as we have the camera here. Delete this one. What next? Let's check also other scripts. Tooltip controller, canvas main. It should include object for operating with these cubes in order to generate them. You need to find this script, cube instantiate, and put it to our canvas main and put corresponding prefabs. Cube blue, cube green, cube red. So next, these functions, red, green, blue, we select them, put our canvas here. Here we'll select cube instantiate red. Here cube instantiate green. Cube instantiate blue. Okay. Let's check the instantiations of our cubes. Where is the camera? Okay, also canvas changes we don't need, we can remove the script and here. Next, camera PT RC. Here we need to drag and drop our camera. Okay. Good. Okay, we can also create red, blue. What's it? Why I didn't change the parent? Okay, let's check this moment. It should be located here on the base origin. Why didn't change? Because name is different. Let's copy it and replace. So here it should be the same name, base origin. So now we won't have this error. We can show tooltips, so it will show us corresponding tooltips of the object we are interested in. Next, let's move to the MATLAB program. We'll create new file, Part4. Firstly, I will copy this part from the project I tested things. Put here, save it, name as Part4. Here we have the manual mode of generating cubes, and also let's add the operation to create objects from the MATLAB. The ability to create it from the MATLAB. So again, I will copy these functions, a new object, put it here, save, new object, and we will, once we grab the cube, we will create another object. So here our init parameter, we will send it to the unity. If init equal to 1, it will be red cube. If init equal to 2, it will be green cube. If init equal to 3, it will be the blue cube. So firstly, when we start the unity, the green cube is created by default. We can see it from this program. So when we started, the green cube is instantiated. So this one corresponds to the green cube. So during the next step, for example, we will create the red cube. So here the init equal to 1. And next step we will create the blue cube, init equal to 3. So we do it 3 steps. We have 3 objects. So here we have the loop from 1 to 3. As we created the new case here, we also need to add corresponding changes to our server script. New case to the server script. So we open server script. Here scroll and find our cases. What we need to do here is to add a new case, a new object. So I will copy it. Here is a new object case, exactly the same we wrote in MATLAB. And we need to add a new function, modify cube. Here we will receive the data which corresponds to init, and based on it we need to switch generate cubes. So modify cube we are interested in. Again, I will copy it. So modify cube, we receive the init parameter. If it's 1, we instantiate the red cube. If it's 2, we instantiate the green cube. If it's 3, we instantiate the blue cube. So we need to firstly find the object to which our script is attached. Our script is attached to the canvas main object. So here is our script cube instantiate So we get instance to it, cube instantiate, and then we modify the parameters. So let's save it and check whether it works or not. Okay, here one more. Again, let's also take a look to the positions we're interested in. Here is the position of the cube, and here is the position of the camera we need to put to our program, and also these positions of sorting places. Let's take a look at them. So this position will be the same for 3 cubes. So here it is. This one, here you can write 6, 2, 4, 1, and this one can be this one, Z, and we can adjust the Z later. Next, the camera position, this one same, this one, and also this one can be modified later. Next, the sorting places. Here's the red sorting, this value, Y sorting, Z sorting. Z also can be different. Next, the green sorting, it's these parameters, this one, and the last one is blue sorting, 0.3, and this. Okay. Okay, next let's try to test the MATLAB program. So we click run and see how it will look like. Okay, working. So some of the parameters can be adjusted to get more precise positioning of the cube. But it's a general idea how to make the sorting and also how to see corresponding parameters here. Again, this is the local positions. So in order to make correct calculation, the script can be adjusted, or these tooltips can be located in some, attached to some other parameters. So that's all for this part. Thanks for watching. Also, let's delete the scene number 2 and rename our import scene copy to the scene number 2. Scene 2.